we're going to continue in our discussion on creating linear functions to model data by talking about cost, revenue, and profit. So just big picture here, let's say you want to run a business. Your cost function tells you how much does it cost you to run your business. Do you have to hire employees? Do you have to get a warehouse space? Do you have to pay an electricity bill? Things like that. Your revenue function is how much money you bring in. So let's say you're selling cupcakes for $3. Well, you're going to make $3 for every cupcake that you sell. So your revenue function would be 3 times however many cupcakes that you sell. Your profit function is how much you actually made, right? So if you sold 100 cupcakes, you brought in $300. That's your revenue, but you didn't actually make $300 in total because you might have spent $20 on ingredients. You might have spent $100 on employee salaries. You might have spent $50 on an electricity bill to run the oven. So those three functions are all related: your cost, your revenue, and your profit. Those three functions are summarized at the top. What is particularly important is that the profit function is the difference of the revenue and the cost, right? The difference of how much you brought in, subtract how much you had to spend out in order to even make some money. So let's look at this example here. Example 11, we have Alina. It's a pretty name. Alina is starting a power washing business. She's charging $35 to power wash driveways and sidewalks in front of the home. Her startup costs include the initial purchase of a power washer for $330 American dollars. And she has to pay a $2 fee to the HOA, Homeowners Association, for the use of water for each house. So let's start looking at some questions here. Part A, write a linear cost function for power washing at X home. So how much does it cost her to power wash X number of homes? So I'm going to just start off with C of X because the cost varies depending on how many homes she washes. First things first, she definitely has a fixed cost. She will certainly pay $330 before she power washes a single home, because she can't power wash a home if she doesn't have the power washer, and she has to buy the power washer. So I'm going to go ahead and add in a $330 right here. I'm just putting it at the end to match this format. But she also has to pay the Homeowners Association a fee of $2 for every house that she washes. So if she washes one house, she pays $2. If she washes 2 houses, she pays $4. 3 houses, $6. So generally speaking, she pays 2x. I don't like the way that looks. So her cost to wash X houses is 2x plus 330. 2x is going to the Homeowners Association, and the 330 is the cost she paid for the power washer. Let's write her revenue function. So how much does she actually make? Well, that also depends on how many houses that she pressure washes, because she's charging $35 to power wash a driveway and the sidewalk. So if she does 1, she makes 35. If she does 2, she'll make 70. That's 35 plus 35. So generally speaking, she's making 35x, where x represents how many homes she goes and pressure washes. Now we're come to where we're being asked about her profit function. The 35x is what she brings in. The 2x plus 30 is what has gone out. So how much does she profit overall? Well, we take what she brought in, the 35x, and we have to be very careful here. Back in lesson, I have a sheet of paper over here. That's why y'all see me looking over there. It has all the lessons that we do. Because I really do want y'all to understand there's a reason why the course is set up like this. There's a reason we do this before that or that before this, because to get the profit function, just by definition, sitting right there, the profit function is her revenue minus her cost. Right? Subtracting those two functions. I hope that sounds familiar, because in lesson 4, we talked about algebra of functions and subtracting functions. And I made a particular point that when you're subtracting functions, you have to be careful because you need to distribute the negatives. So we will take the revenue function, and what we will not do is just stick a minus sign between the revenue function and the cost function, because we need to be using parentheses, because we need to distribute that negative. So if our profit function is really 35x minus 2x minus 330, 35 minus 2, those are like terms. They both have the x. We can combine them to give us a profit function of 33x minus 330. That's our profit function. Part D asks us, how much profit will she make if she washes at 50, if she power washes at 15 homes? Well, we need to plug in 15, because remember, x represents how many homes she has power washed. So P of 15 is 33 times 15 minus 330. Calculator. You all will be using a scientific calculator. More specifically, y'all's calculator will look like this. When we get to Unit 3 in the course, we'll be using graphing calculator, so it doesn't really matter though. 33 times 15 minus 330, $165. And that is dollars that we're talking about. How many homes must she power wash to make 330? That's a different question, right? It's not saying, we certainly do not need to be plugging 330 into either of these equations, because the 330 is how much she has made. To make 330, to profit 330, I'm going to set the profit function equal to $330. And I want to solve for how many homes, and how many homes is represented by x. So I'm setting the profit function from part C, which is 33x minus 330. I'm setting that equal to 330, and I'm going to solve for x. I'm going to add 330 to both sides of the equation. So I now have 33x equals 660. And now I'm going to divide both sides of this equation by 33 to see that she needs to power wash, I don't know why I did that, I could have done that, 20 homes in order to make $330.